Hello everyone. Today we have Professor Dr. Werner now with us, all the way from Germany, and it's our pleasure to have his interview today. So, Professor Werner, are you liking here the campus of IISER Bhopal?
Very much. Thank you. Thank you very much to those who invited me here to visit IISER Bhopal. It is a very nice campus. I just arrived. You have a wonderful guest house and wonderful facilities here.
All right, glad you are comfortable here. Is this your very first visit to India here?
I've been in India perhaps altogether 10 times.
Oh, that's great.
So many times in Mumbai.
Mm-hmm.
I've been to Kanpur, IIT Kanpur,
IIT Bombay, IIT Kanpur,
IIT
yes.
Guwahati, and I've been to Bangalore, to different
I see.
institutes,
Great.
and also to IISER Trivandrum.
Mm-hmm.
Yeah.
Nice. Okay. Professor, would you guide us briefly through your academic journey? How has it been through your student life, maybe since your school days, and how you landed into research and maybe chemistry specifically?
Yes, of course. So also in Germany we have a system with a high school.
Mm-hmm.
Only if you finish the high school, if you finished, I had to finish 13 years of school. And those who finish 13 years and not only 10 years are allowed to study. So we have an entry qualification which is then automatic with completing this part of the special track of the high school.
Mm-hmm.
I've always had a passion for science.
Okay.
So it was obvious I would study science. But originally, I have to admit, I applied to study biology. At that time, in 1987, this was a very popular subject. And there was a twist of fate because my letter, which I sent by registered mail, did not reach the office on time. So I have not been admitted to biology studies. So
Destiny, I would call.
Yeah, so within 1 month I changed my direction and then went to study chemistry, and it didn't hurt. So of course that taught me early a lesson that not everything can be planned.
Mm-hmm.
Also not in the careers, and certainly I did never plan to become a professor of chemistry.
Right. Okay. So, so destiny has its own ways.
Absolutely.
Also, maybe it happens that when we are a young learner in school, it happens that more we see around us is nature, whereas chemistry is something which needs a lot of techniques, right? A lot of studies to understand the phenomena as happening. And biology is something a young student from maybe middle school and all can relate more. Maybe that's why most of us get interested in doing biology first.
Yes.
And yeah, but I feel that your interest in biology still pertains. I mean, it still reflects in your current researches, and because you do a lot of studies on membrane transport and all of that. So maybe I think still some part of it you are still connected to it.
Yeah, absolutely. Yeah. Of course, science can sometimes been drawn as a pyramid.
Mm-hmm.
And depending on your viewpoint, where your inclination is,
Yeah.
you can put physics on the top
Yeah.
or biology on the top, right? Because the physicists will, of course, argue that many chemistry phenomena are based on physics. The chemists will argue that many biological phenomena are based on chemistry, and so on. But you're absolutely right. Biology is a little bit more on the observing, on the descriptive side. Chemistry goes a lot more in depth, and physics even more just very heavy formula based, right? So I always thought chemistry is nicely positioned in between physics and biology.
Mm-hmm.
So whatever you prefer, you can make it more physical, or you can make it more biological.
Yeah, I agree. So maybe while you were in your undergraduate, let's say, or even in your master's, were you very sure that, okay, I have to pursue supramolecular chemistry or maybe something maybe correlate it with biological applications. When exactly did that interest start, or maybe when did you take that decision that okay, into chemistry I would prefer something like this, or maybe when the point comes while a student has to do their master's thesis or choose a field for PhD, when exactly did you decide that?
Well, supramolecular chemistry is still a very young field, and it really started with the Nobel Prize given to Graham, Lane, and Peterson.
Yeah.
And I think it was 1986 or 88, I forgot exactly, but it was around this time. So basically when I started to study. So the field was very young, and I could not plan to go in this direction.
Yeah.
But of course, if you plan a researcher career, eventually you will have to pick independent research topics.
Exactly.
And then you pick perhaps a current one, because that's where there is a lot of energy, where lots of discoveries can be made, right? A vibrant field. Supramolecular chemistry was one of those, but another field, which I actually wanted to pursue first, was the field of ultra-fast spectroscopy, where we have also had a Nobel Prize, a recent one to Ahmed Zewail. It was coming a little bit later than supramolecular chemistry. So when I started my career as an independent researcher, one idea was to go in the direction of ultra-fast spectroscopy, which of course is closely related to photochemistry also and photophysics. But it turned out to me that this was instrumentally too demanding. I would be too much dependent on others to have the instrumentation available. And then we had some nice projects going in supramolecular chemistry. And then I redirected my path towards this area.
Right. Speaking of Nobel Prizes, like we know that this year in 2025 it was awarded to Professor Robson, Professor Omar Yagi, and Professor Kitagawa on MOFs, metal organic frameworks. Do you think there is still any particular area in supramolecular chemistry which has the potential in the upcoming years to, maybe get awarded with a Nobel Prize? Just a prediction.
Yeah, I mean, of course, the areas where Nobel Prizes are awarded, and also the researchers who receive Nobel Prizes, are always a matter of the viewpoint, of the opinion, also of some debate. Of course, the scientists being selected are always brilliant scientists. And now you may wonder, why do you award a Nobel Prize for a certain direction? And perhaps is less the question where most applications are coming from, or where perhaps more fields can spin off from an area. But I think what is very important that the researchers who get this prize have established a track record that many other researchers around the world usually have followed their path, have changed their directions and migrated in this area. So I think that is the important direction. The metal organic frameworks, in fact, have not yet lived up to their potential in terms of real life applications. But they have stimulated, of course, a lot of chemists around the world. Now, I don't think from supramolecular chemistry there is a direct spin-off to give yet rise to another Nobel Prize. But I think several areas which have already also been considered with Nobel Prize are very closely related to supramolecular chemistry, and in fact even metal organic frameworks are also in some sense a spin-off in supramolecular chemistry, because supramolecular chemistry laid the foundation to build really, really large architectures. And that is, of course, brought to excellence with the MOFs. But also, if you look at the applications of MOFs, you would be thinking about perhaps materials which can store gases. Then you are there at supramolecular, intermolecular interactions again. And other areas which are also closely related is, for example, the Nobel Prize for fullerenes, and also the Nobel Prize for graphene.
Absolutely. So yeah, there are a lot of such fields that do have such potential. Okay. So since it has been a long time that you have seen a lot of switches and turns into the trends, the way people have been working in supramolecular chemistry, have you ever had any one such eureka moment while maybe you were a young researcher, when you were in your PhD, that maybe completely changed your perspective towards research?
Well, during PhD, I was not yet interested in supramolecular chemistry. I was dealing with photochemistry, which went in quite different directions. I think what I learned, for example, during PhD was really how to write manuscripts, how to present stories in a nice way, how to present what you discover in a convincing manner and publish it, then ideally at high level level journals, and that turned out to be a lot of fun. So whenever you make a discovery, you don't know how important it is or how important others consider it to be, but what is important is that you have your own fascination for the topic and that you are enthusiastic about your discovery, right? And then that you describe it and convey it to others with really glowing eyes, right? And a lot of enthusiasm. So I think that is most important. Less than worrying about how important is what you discover. You have to like it.
Okay. Maybe we have to be the more passionate we are towards what our work is, I think the better we'll be able to present it that way.
Yes, and I would say this is a guiding principle. Always try to do, especially if you are a researcher, if you are a student in the sciences, always try to do what you really enjoy. If you come one day to the lab and you really don't know what to do and you question why you do it, then either change the topic of your research or study something else. But that is most important. I think this is what keeps us going and what infects also others then.
Absolutely. Agreed. Any one such tip that you want to give young researchers, that maybe what they perceive research as before entering into research, it's not at all like that. Maybe you had one such misperception before entering into research that, okay, being a scientist is going to be like this, but that got completely changed when you actually landed into the field.
As I mentioned, I mean, I never planned to be a scientist. When I did bachelor level, I wanted to complete my bachelor, then I wanted to complete my master's, then I wanted to complete my PhD, and this was sort of, in chemistry at least, simply the normal route, right? So I did not plan that. But as you are studying, of course, knowledge builds up, and then you can put one and one together at one point, and then you have some ideas, and then you try to test your ideas, and then it works. So everything builds up on each other, I would say. So I would absolutely not recommend to rigorously plan a career. That also speaks, of course, against accumulating publications in a systematic manner in order to qualify for the next step. Publications are important, right? But they should be self-motivated. You should really like what you write. If you write up your results, you shouldn't do it to get another entry in your CV. I mean, what I personally enjoyed in my research career was collaborations with other researchers, other laboratories, with students in their own lab, with professors at other universities. I had the chance to spend some visits at other universities back then, in Germany, also one time in Switzerland. to go there with my samples and to do specialized measurements. And this was really inspiring me then during PhD to see different research environments, see different people, see that different professors are very, very different and have different approaches. So try to accumulate really experience. This is the key.
All right. Did you face any major challenge, probably with any project not working? And I think this is a part of research, especially when you are a young researcher. Sometimes you try new projects, you design something very ambitious and you just plan that it's going to be very cool and it's going to be very impactful, but then it doesn't work out, maybe on the synthetic level, or maybe it doesn't give out the desired results.
Obviously, projects can fail. The first 6 months of my PhD, I desperately tried to synthesize a silicon derivative in a 5-membered ring. It never worked. But then I had this insight, I will never get there in a short amount of time. But during that time, I'd already shopped around and looked around which other projects are feasible in this particular research group with Waldemar Adam then at the University of Würzburg. And I found an interesting new project which I suggested to my professor, and he was smart enough to let me go and let me change topics and use my energy in a good direction, and then it was successful. My personal approach also to own PhD students, which I'm educating, is that I do not assign them a single project. I usually try to trust them, maybe not immediately at the beginning, but after a few months with 2 or ideally even 3 projects. And that is my philosophy, both as a professor, but also for a PhD. It's a good approach. We have a saying in Germany that a chair is only stable with 3 legs, right? So 1 leg is not enough, 2 legs neither, but with 3 you can sit stable, right? And I think that is also one important aspect, that one pursues perhaps 3 different lines. They don't have to be completely different lines of research, but it could be an experimental one, but you also do the theory, or you try different applications of something, and that proves usually very important. And this is just a reflection that projects can sometimes simply don't work, and you have to abandon them.
All right. Like you talked about collaborations also. So currently, is your group more focusing on collaborating regarding biological applications, or would you prefer collaborating for a synthesized molecule and then you prefer studying it into more detail?
I think we are flexible. We are very flexible with that. We all know that synthetic work is extremely work intensive, and there are many groups out there in the world who invest a lot of energy in synthesizing new molecules, but they may not have good applications for them. Let us take, for example, fluorescent dyes, right? This is a typical example. Then there is no problem asking a research group who has in stock a whole large portfolio of fluorescent dyes, and you are looking for a particular application, to ask this research group to simply supply the compounds, because work should not be wasted, right? So if different research groups synthesize the same molecules in different places of the world, there's usually no added benefit to that. But regardless of that, apart from that, no real preference. It can also be in other cases that we would synthesize a molecule which is then popular for others to use.
All right. While as a PI yourself, while hiring a new PhD, what set of qualities do you look for in them?
Well, we are actually hiring right now. We have a large project. We are hiring right now at the moment in this February, March, hiring PhD students and postdoctoral fellows also. And what I can state is, of course, that the profile of the applicants is also changing with time. So I observe that the profiles have changed quite a bit in the last years of the applicants, and it makes it more difficult for me actually to really pick out the best candidates. But obviously, a personal interview is always absolutely needed to convince myself, and then one notices, is this particular potential researcher, is he or she flexible? Can he really present the science in this interview very well, which he did? And is he enthusiastic about science? So I'm looking more for these aspects than for detailed knowledge on a particular subject.
All right. So, for example, while hiring students itself for PhD, would you prefer someone who has done a couple of very challenging projects, or someone who has had a decent number of, comparatively more number of publications, which also proves a lot of efficiency?
Yes,
So
absolutely. I mean, if these are all first author publications of a group of, let's say, 4 or 5 co-authors, then of course this demonstrates something.
Yeah.
It demonstrates that this particular student has done a lot of work. It does not yet demonstrate that the student has really written the paper, right, which still needs to be found out, and whether he had the idea for the project. So having many first author publications is ticking only one box, but it tells you nothing about the creativity of the student and about the real motivation of the student in science. And if you compare different research groups, of course, there are also big differences in publishing. So this is only one aspect, but many publications will, of course, send a signal and perhaps give you access to an interview spot.
And that's where the interview comes in.
Yes,
Yeah.
this is when the interview takes over. Similarly, grades in the transcript, I think they are also very important. GPAs are very important, and a perfect GPA will also probably get you an interview invitation. But this, of course, usually tells very little about your practical skills. And if you are very smart but just don't get your projects finished, then there is also a different issue.
I agree. Professor, do you have any, what are your other interests other than research and chemistry?
Well, let's say the city where I'm from, Bremen, has a football club, so I'm a great supporter of the football club. Also played football myself, also in university teams, like at the University of Ottawa when I did my postdoc. So this is one interest. I'm very interested in ancestry, where our ancestors came from our own family. This is a very exciting field of research where I'm, once in a while I'm getting involved in.
That's interesting. All right, so Professor, we are looking forward to your talk tomorrow at the conference, and it was really nice talking to you. Thank you so much for giving us your precious time here. Thank you so much.
Yeah, thank you very much for the interview and for questions. Thank you.
Thank you.